First of all, thank you all for coming tonight. What I want to introduce is we did a film with Dr. Serpil Guran. Our students go down to the Rutgers EcoComplex, which is a wonderful facility that's located in Bordentown. What they do there is they try to show students some sustainable new ideas that can then be utilized in an economic sense. So it's sort of the marriage of new sustainable ideas with the economy. And so we've tried to, as John just mentioned, we've tried to teach that to students. We've tried to talk about the idea that there's some beautiful new things that are happening. So they see how a landfill is using the methane gas at a cogeneration plant to generate electricity. And so what I want to tell you is that I have a short little video that was done with Dr. Serpil Guran. We did it on the fly. I am not a TV person, so don't expect good production value. And after Dr. Guran does a little educational piece about what's happening in New Jersey, one of her many, many items that she's working on, then we have the student's voice. And I think it's important. Again, you'll notice that it's not really professionally done because we kind of grabbed them and said, did you want to speak or have a voice at Thursday night's event, because they've been part of this. So welcome the students and welcome Dr. Serpil Guran. We have a little video that's about 12 minutes plus 4 minutes of students. Thank you.
Hello everyone. I'd like to thank everyone, and especially Westfield High School science teacher, Mrs. Judith McLaughlin. My name is Serpil Guran. Now I'm going to move from the camera. My name is Serpil Guran, and I serve as the Rutgers EcoComplex director. And Rutgers EcoComplex is a clean energy innovation center. It was originally formed as a Rutgers University's one of the extension centers, but since 2011 we are also promoting center as a clean energy innovation center. The center is a multidisciplinary environmental and clean energy innovation center, and it harnesses research and education resources towards the development and industrial application of innovative clean energy and environmental and agricultural technologies. The center serves as a business incubator and houses currently 13 startup companies. We are part of national and international incubator organizations. Also, we are part of Incubate Energy, part of our Department of Energy. As I mentioned, Rutgers is serving as a clean energy innovation center. Also, very recently, we launched an accelerator. It's called Ignite, Rutgers EcoIgnite, Clean Technology Proof of Concept Center and Accelerator. As all you know, if you have a young idea and young startup, you may not right away commercialize your technology. Basically, at our center, we have the concept assessment ability, and then development and scale up, testing and verification your technology, and help you launch and your technology. So EcoIgnite is targeting especially creation of ecosystem in clean energy development and innovation in state of New Jersey. Our goals is, in addition to solar, also promote solar, wind, and also energy storage, battery technologies, also energy generation, renewable energy generation from biomass, especially from food waste in New Jersey, that I will be mentioning further down the road. But why we have especially paying attention to energy storage and battery technologies, because solar and wind, and so we have to store these technologies when they are not available, when the sun is not shining or when the wind is not blowing. So basically, I was asked to provide our thoughts about New Jersey's renewable energy generation capabilities. As all you know, New Jersey has several pathways. We can say that currently solar technology is pretty well advanced in the state. This is the number of 2,300,000, almost like 400,000 kW, or 2,300 megawatts of installed capacity of solar, including residential and commercial. And also there is a new approach integrating wind and renewable energy also, especially in the offshore wind form into New Jersey's renewable energy generation capabilities. But especially now, in addition to solar and wind, I'd like to provide some thoughts about bioenergy, especially sustainable bioenergy. Before even I move to that, I'd like to provide you, because New Jersey, happily I can announce that New Jersey is back to business on reducing greenhouse gas emissions and also mitigating global warming. So with that, first I'd like to share with you New Jersey's CO2 emissions from by sector. You can see that the transportation takes almost like a little more than 50%. And also commercial, electric power generation, residential, industrial makes the other half. So CO2 is mostly generated from transportation, but also other sectors. So let's take a look at the CO2 emissions from fuel types. You can see that New Jersey still generating New Jersey's CO2 emissions mostly is coming from petroleum. As you would know, it's for transportation. Everybody is driving their single cars back and forth. So we need in New Jersey infrastructure for public transportation. That's really important part. But also we have to convert those transportation into maybe electric vehicles and also more cleaner vehicle technologies. And the second part, large greenhouse gas emissions is coming from natural gas. Mostly it's for heating and also power generation. As you know, state lately invested and generating a large amount of power from natural gas. Coal generation, these numbers are by 2015, Department of Energy's latest numbers. These are the current available numbers. But I have to draw your attention, these are 2015 numbers. So still coal is listed as about 2% of the CO2 emissions. But still you see that we have a lot of emissions coming from fossil fuels, including natural gas. I mentioned you all about New Jersey's renewable energy generation potential. Rutgers EcoComplex assessed New Jersey's biomass energy potential in New Jersey, and we updated that study. Originally we did it in 2007 and then 2015. So basically with this with this assessment, we understood that New Jersey has a lot of waste in the biomass form. And New Jersey's bioenergy can be generated from organic waste. So we, just to keep short, we created several greenhouse gas reduction scenarios. And based on the scenarios, we said, based on what scenario, how much greenhouse gas reduction is possible. Because of the time limitations, I will only share with you only food waste anaerobic digestion to energy potential. Because as you know, last year there was a bill signing that New Jersey, I believe, from schools and food waste reduction by 2030. But also there is another bill introduced, hasn't been signed yet. It's also food waste recycling. So as you know, there is a national trend, international trend on converting or diverting organic waste from landfills. That's why I'd like to especially share with you these food waste related greenhouse gas reduction potential. So with our scenario, we created, if we have the ability to collect all food waste, generated all food waste, and if we have the ideal anaerobic digester, how much we could generate, how much gas we could generate, and how much power generate, additional power generation, and then that, gas also can be a feedstock fuel for transportation. So we have two separate lines just to give you an idea about food waste, how food waste to anaerobic digestion can be a great pathway to create renewable energy but also reduce greenhouse gas emissions. As you could see, from the chart, on the left side, you can create this, how much tons per year we have organic waste. So then this blue chart, column shows you that potential power generation from food waste in New Jersey per year, megawatt hour per year. And then we said that same amount of energy, if it's coming from coal, how much carbons can be avoided, okay? And then we created this scenario, and this green bar also is basically a recycled carbons and the potential CO2 avoided emissions from food waste. It is really important. While you're generating renewable energy, it is possible to reduce greenhouse gas emissions. But then we compared our calculations with GREED, a national model on greenhouse emission reduction model, Department of Energies. So you can see that potential avoided CO2 emissions. So basically, organic waste, it can play an important role creating circular economy and creating general renewable energy, generating renewable energy, but also reducing greenhouse gases. And also, I'd like to draw your attention, these calculations did not include potential greenhouse gas savings from the digestate, which can displace petroleum-based fertilizers. So these numbers will be even much better. So let's take a look at if we use the same biogas, if we use that biogas as transportation fuel and displace rather diesel and gasoline in different ways, and how much CO2 reductions is possible. So you can see the numbers here, and again we compared with GREED, and you can see that it's even negative emission, reduction is, negative emissions we have. So these are great, pathways that we have to really consider in the state. Instead of sending our organic waste into landfills, also sending our waste into directly to composting, industrial composting. And I know this is a school and also a school panel. I have to draw an attention that we have to make sure that we are trying to utilize the most important way, the most beneficial way of our resources. So basically, I'm not going to read the whole numbers, but power generation potential that I provided you, and then potential CO2 emissions, and then I am just summarizing here from if it is used for transportation. So basically, how to reach to state goals, that's very important. We have to create effective regulatory management and implementation infrastructure because they are the most important items to successfully achieve bioeconomy goals. And obviously, we need to have institutional infrastructure. We have to have supporting regulations, and also we have to have market-based incentives, and also market transformation through technological innovation. When I promote, when I mention to you anaerobic digestion, it is not like a rocket science. Europe is almost 1,000 light years ahead of us. Europe is doing this, why not us? Instead of sending our organic waste, we have to utilize it we have to most efficiently utilize it. And also we have to understand, utilize the systems approach for, where the opportunities and the largest opportunities are, and how various strategies and policies might impact each other.